All right, so this week we're going to start off looking at chapter 9, okay, which is on a different way we can do graphs. We'll talk about two different methods. Today we're going to talk about what's called parametric, and tomorrow we're going to look at another way called polar. So this is a new mode of graphing that we can use on the calculator. And parametric basically allows us to draw things that we couldn't normally draw as a function. So remember, y equals. Those are things that pass the vertical line test, which means if you put a vertical line, it never hits it more than once. Well, in this graph, it hits it a bunch of times. This is not something you could sketch in y equals very easily. Okay? Neither is something like that, or this last one. Now, some of these equations a little bit more complicated than what we're going to be looking at this week, but maybe the ones like on the ends, those are a little simpler than the one in the middle. But still, none of them pass the vertical line test. So not easy to draw these in the system that we're used to using. So we're going to take a look at what's called parametric. And the main idea, let me show you on the calculator first. If you press mode, you get three options. On the screen. Function is the one, well, actually you get three that we're going to use, but there is a fourth one. Function is the way we've been doing it all year. That's y equals, we can type in a formula. We're going to put it on parametric. Okay, so let's put it on parametric, hit graph, and you're going to notice a couple things right away. In order to type something in parametrically, you need to type in a system of equations. You need to type two things in. What I just put a box around is enough information to create one picture. Whether it's a curve, or a circle, or a line, who knows what it is. But that is enough information to generate one image. The idea is you have one formula that generates the x values, and you have a different formula generating the y values. So it's like you're breaking a coordinate down, and you're saying use this formula for the x, and use a different formula for the y. We usually do it all in one. We just use one formula. Now we're going to break it into two. Right? That's the idea of parametric. Two equations to make one graph. So let's go back here. And let's call these two different functions that we're going to use. I'll just call one of them f and one of them g for what I'm about to write down. These functions basically are defined on what we call an interval. An interval has a minimum and a maximum value. And the idea of an interval is if you look at your equations, it basically tells you the smallest value you're allowed to plug in for t and the biggest value. And if you go to window, you will see that the interval is part of the window. That's something new we've never had in the window. We've had the x-min and y-min and max, but we've never had this t-min and max. Well, t-min is the smallest number you can plug in for t, and t-max is the biggest. All right, so that's going to be part of graph typing in your interval. I'll talk more about the t-step. That's very important, but not right now. All right, so you're going to be given an interval. If you plug in all the different numbers in that interval that you could, and then when I say all of them, I mean you do enough of them that you get a good sketch. Sometimes it's a couple points, sometimes you need 5 or 6 points to make a sketch. But if you plug in all the possible points and graph them, what you end up with parametrically is called a curve. Now, whether or not it's actually curved, well, it could be a line segment, but the curve is the name of the image that you create by graphing all the different points from those formulas. And I'm calling that curve C. So what I could do is I could label these curves A, B, and C, and say to you, look at curve B. I can name the curve with a letter. Or say, look at curve C. Look at the pattern in it or something. So we can name the curve itself with a letter. The two equations that generate the curve, the one for the x and the one for the y, kind of like I showed you on this other screen, 3t minus 2 and t squared minus 2, those two equations are called parametric equations. They are the parametric equations that generated the image we're looking at, the curve. And notice the variable, t. When you do things using parametric equations, you don't use x as the variable. You use t. And technically t, the formal name for it is a parameter. I like to think of a parameter as a variable that has limits. It's a variable that has a minimum and a maximum value that you're allowed to use. But really, a parameter is just another name for a variable. Okay, and if I go back to that other screen where you can look at the two equations, you'll notice t's, not x's. And the way you get the t, well, it's the same button you would use if you wanted to put in an x. This button right here, that says xt theta, that button will be a t now when you press it. So if I clear this out, I want to type in 5t. 5t. It's a t. If you go back to y equals, it'll be an x again. So parametric, let me make sure I didn't skip anything. I don't think I did. No. So because it's a parameter, and you're telling me a minimum value and a maximum value that I can use for the parameter, parametric curves have a start point and a stop point. They do not go on forever. They start somewhere and they stop somewhere. It could be in like the graphs like this, it's kind of hard to see the start and the stop point. Something simpler like a circle, start and the stop point were the same. I could also draw a circle like this. Different start and stop point than up here. So sometimes you can't really tell where the start and stop point is unless you actually watched it being drawn. Because after you draw the circle, you don't know where I started or stopped. You can't tell after it's already been drawn. Even with a line segment, unless you were watching, you don't know which way I do that. Did I draw it up and to the right or down and to the left? There's a difference. If I ask you which one of these is the start and which one's the stop, you have to know which one's which. And where the curve will start and stop, well, depends on the values you're allowed to plug in for t. In a problem, that's part of what they'll tell you. They will say to you, plug in these numbers for t. So like in the first one we're going to do, I'm going to allow you to plug in numbers between 0 and 1 for t. That's it. We're not doing it yet, but you can't plug in 2. You can't plug in -3. You can plug in numbers between 0 and 1. That's it. So suppose that I have a domain or a parameter defined from A to B. In a real problem, the A and the B will be numbers, like 0 to 6, 2 to 7. But there'll be a low value and then a high value. If you want to find where a graph starts and stops, there's 4 calculations you need to do. First, you have to find the x value of the starting point and the y value of the starting point. And the way you find the starting point is you look at the low value in your interval and you plug that number into the formula for the x's and the formula for the y's. So let's say, like on this one, let's say my parameter went from 2 to 8. If I wanted to find where this graph starts, that's the number that controls where it starts. I would plug that number in for t in the x formula, and then I would plug that number in for t in the y formula. That's how I would do it. Now, if the 2 controls where it starts, what number do you think controls where it ends? Yeah?
1.
Yeah, but, well, which number?
8.
The 8. So the 8 controls where it ends. Plug the 8 in for t, and plug the 8 in for t, and you can see where that ends. So in our case, the end value, I didn't call it 8, I just called it b. Plug b into the x formula, and plug b into the y formula. Now, this doesn't tell you very much about what the graph looks like. It gives you a start, it gives you a stop. Maybe it's a straight line. Simplest case. Maybe it does something like this. Who knows, right? We don't know what it's doing in between the starting and the stop point unless we check more values. And that's what we'll use the calculator for. Because sometimes you have to sketch, I don't know, 50 or 60 points. Well, by hand, that's a lot. It's a real lot to sketch. But for the calculator, to plot a few hundred points, it'll take seconds. All right, so any question on this idea? Plugging in the first number to your formulas to get your start, and the second number to get your stop. Let's try it. We'll graph this, but you don't need your calculator to do this step. So here's the formula that's generating the x values, 1 minus 2t. Here's the formula that's generating the y's, 2 minus t. And here's your interval. This is the interval for the parameter. It's what t is allowed to go from and to. From this to this. Okay, find the endpoints of the curve. All right, let me do it up here so that way I can still see all my information. What number controls where the graph starts in my interval? Yeah?
0.
0. So you want to plug in 0 and get the x value. Plug in 0 and get the y value. And when we're done, we'll have a coordinate for the start. Then we'll do the end. All right, if we plug 0 in for t here, Matt, what's 2 times 0?
0.
And 1 minus 0?
1.
1. And Abigail, what's 2 minus 0? 2. So this graph starts at the coordinate 1, 2. And it ends, Jeff, what number am I going to plug in for t to see where it ends?
0.
0 tells us where it starts. 1. So we're gonna plug in 1. And Casey, if I plug in 1 for t, what's 2 times 1? And 1 minus 2? What is it? 1? Not 1. Negative 1. All right? And Francesca, what if I plug in 1 here? What's 2 minus 1? 1. There's your endpoint. So this graph is going to start at 1, 2. All right. Let's think about that. It's going to start here, and it's going to stop at negative 1, 1. Negative 1, 1. That's the finish. Now, it will be a line segment. That's how it's going to look. But when we type this in and graph it, what direction is the graph going to be drawn in? Imagine this line segment kind of being animated and starting. What way is it going to go? Yep.
Down and to the left.
Down and to the left. We've never graphed anything all year that's ever gone to the left. Every time you graph something, it starts on the right edge, and it starts on the left edge, and it goes to the right. This one's not going to do that. Okay, so let's look at how to do it. All right, so first thing, I already showed you guys, put it in parametric. If you have anything in the x and the y, go ahead, clear it out. And you're going to have to use 2 of these equations. You have to use 2 from the same set. So you could either use these 2, or those 2. And there's more if you scroll down, but pick 2 from the same set. Okay, now type in the equations. 1 minus 2t, 1 minus 2t, minus 2t, and 2 minus t. So that's the first thing. We got our equations. Now we need to go to the window. So let's go like this. Let's put this here. And go to your window. What we need to do now is set our window. On the calculator, this value that controls the start is called the minimum value for t. It's the t min. This controls the highest value. This is called the t max. So we have to put those in. T min is 0. Press. So T min is 0, T max is 1. Now, the T step, that's important. The T step tells the calculator how often do you want to graph a point to get a picture. Because the way the calculator graphs something parametrically is it goes like this. It puts a bunch of dots, and then it connects 2 dots that are next to each other with a perfectly straight line. That's what it does. So if you're graphing something that's curved and you don't graph enough points, like let's say you want to do a circle and you only graph 6 points, well, it's going to look like a hexagon because you haven't done enough points to make it look like a circle. So our T min is 0. T max is 1. For T step, it's a good idea to try to pick a T step that divides into the T max. Because think of it like this. These are steps. You're starting at 0 and you're ending at 1. If you step by 0.1, what's going to happen is this first step will be 0.1. The calculator will plug 0.1 in for x, it'll plug it in for y, and it'll plot a point. And then it's going to do 0.2. and then it's going to do 0.3. And it's going to keep going until it gets to 1. So it's going to plot a point every 10th. Now, for a straight line segment, that's more than enough. Now, let's say you went by 0.3. So you're going to plot 1 and 0. Then the calculator is going to let t be 0.3. And it's going to plug that in for x and plug that in for y. Then it's going to do 0.6. Plug that in for x, plug that in for y. And then it would do 0.9. The problem is the next step would be 1.2 if you go by 0.3. What was the t max? Yep, 1. So what ends up happening is this is the last point that it can actually plot. So you end up with this little gap in your graph. If you were doing a circle, it might end up looking like this. You end up with a tiny gap because your t-step didn't land on the t-max. Okay, so try, if you can, to make it land on it or pretty close to it. 0.1 is a good number to go by in this case. So let's put that with it. Okay, so there's your window. And remember how we said it's going to drive from the upper right to the lower left. It's going to happen quick, so watch it as it does it. I'll even zoom in so it takes a little longer. I don't know if you saw it, but it did go right to left. If I want to slow it down, I can tell the calculator, all right, I want you to go by 0.01. So now it's going to graph. Think about if you were counting from 0 to 1 by 0.01, 0.01, 0.02, 0.03, 0.0, all the way up to 1. If you count by 0.01 from 0 to 1, that's 101 steps. That's how many numbers, that's how many things you'd have to say to count from 0 to 1. And you can see it graphs it much slower. You're graphing 101 points right there. Now, if you do 0.001, if you were going to count from 0 to 1 in thousands, you would have to say 1,001 numbers today. At this point, we might be getting to the point that look how long it's going to take to graph it. Still doable, it's going to finish. But, I mean, I had to take a good 10 seconds maybe to do it. Maybe I don't want to wait. Or maybe I have a graph that's so complicated, instead of 10 seconds, it's going to take 10 minutes. If I go to sketch something, and I see that it's sketching it way too slow, like right now, it's going to take 10 times as long as it did before. I think it's plotting over 10,000 points. This is going to take like a minute. I want to stop. I can't press anything while it's graphing. The only thing I can press to make this yellow circle stop spinning is second off. Now, it stopped it. So now I can say, okay, that was not a good t-step. It was way too slow. Let's change it. Let's hit graph. Okay, that's good. I like that. All right. So second off will stop the graph if you get into a situation where it's just going to take like 10 minutes. All right, so any questions on what we just set there in the window? X-min, X-max, Y-min, Y-max, that's all the same. It's just these three things that are new. What type of graphs do you think the step starts to get more important on? This was a line segment. It wasn't super important. Yeah?
Curves.
Curves. Yeah. If you don't do enough points on a curve, it starts to look blocky. It doesn't look right. All right, so is that the only example I have? Yeah, okay. So sometimes what we can do is we can eliminate the parameter. What this basically means is take the parametric equations that you have, and turn it back into the kind of system we're used to. Make it so it's y equals and you have an x on the other side. So when you eliminate the parameter, you are turning it back into the kind of equation that we've been using all year. So let's take example 1 and see if we can eliminate the parameter and turn that back into an equation we're used to. Now, if we look at the graph again, that's basically like a y equals mx plus b. That's all that the graph was in the last problem. It has a certain slope and a certain y-intercept, and it is a perfectly straight line. The only difference is it's not really a line, it's a line segment. So we don't want it to go on forever. We'll talk about that. But the first thing we have to do is figure out the formula for that as y equals. So here's our two equations. What we don't want in the final answer is that. We don't want t in the final answer. So does anybody know what we could do with the x equation that would give us something to fill in for t in the y equation? Have a guess? Something that I could do with the x equation, and then I could replace this t in the y equation. Yeah?
You could solve it for t.
Yeah. Solve the x equation for t. That's step 1. Okay, so let's solve it for t. So that gives me x minus 1 equals negative 2t. And Ethan, what would be my last step to get that negative 2 on the other side?
Divide by negative 2.
Yep, divide by negative 2. So the way I'm going to write it is like this. Negative 1/2 x plus 1/2. That's what you get if you solve for t. Negative 1/2 x plus 1/2. Now, take what you got for t and plug it in. And now you will get an equation with y by itself. Right? Let's do that over here. Well, y will be by itself and x will be on the other side. You're not going to have t anymore. So instead of writing 2 minus t, put in what t equals. Negative 1/2 x plus 1/2. And hello, Bailey, what do I have to do with this negative that's in front?
Distribute it to
Yep.
both halves.
Yep, so I have to distribute that negative out. And just combine your like terms and that'll be your answer. So 2 plus 1/2 x minus 1/2. Yeah, I don't have anything I can combine with the 1/2 x, so that's going to stay the same. And then 2 minus 1/2. What's 2 minus 1/2? Yeah. Yeah, we could just do 1 1/2. If you wanted a fraction, you could do 3/2. There you go. So now you just created a function. Let's graph that, and let's think about the graph we had before and see if they look the same. All right, so parametrically, this is what we have. Let's take this graph, put it here. You know what I'll do? I'll put the equations under it. Like I have to time it just right so I don't get the cursor blinking on it. Okay, so that's that one. Now let's switch it back to function. If there's anything in there, just clear it. And what was the equation we just had? 1/2 x plus, what was it? Yeah, 1.5. Okay, so let's graph it. And let's see if what we have looks exactly the same as what we had over there. Okay, and here's what I typed in. That's a 0.5. All right, do those look exactly the same? Yeah?
Wouldn't it be negative 0.5?
It wasn't 0.5, what we came up with?
No, 0.5.
Yeah, 0.5. Yep. So, do those two pictures look identical? Francesca?
One's just longer than the other.
Yeah, this one is longer on the right. It should stop here and here. How do I know where it should start and where it should stop? What we did earlier. We know that this graph should start and stop between 1 and -1. We got that by figuring out the starting and the stopping coordinates. So what's important are these two numbers, -1 and +1. Your graph should not go beyond -1 or +1. It should go between them. So part of what you have to do when you tell me this answer is you have to restrict the domain like this. Now, you've not only told me what the picture should be, but you've told me where to put it between -1 and 1. And now, by giving me that restriction, it is correct. Okay, so that restriction comes from figuring out the start and the stop points. And that's part of the answer you have to write with. Any question on that? Now, as far as graphing it with that restriction on the calculator, we're not worried about really doing that. You don't have to worry about that. You just have to remember to write that down. Alright, let's try this one. Let's see if we can eliminate the parameter and remember to give me the restriction. So, to eliminate the parameter, let's go back because I don't think I really wrote down step 2. I said step 1, solve x equation for t. Step 2, you want to substitute for t in the y equation. Okay, so that's your second step. So let's try these steps on up. Step 1, solve the x equation for t. Okay, how about Tyler? Can you tell me what I get if I get t by itself in that equation? What about my x? Where we got to? So what's preventing the t from being by itself right now? The minus 1. So what would be the opposite of a minus 1? Add 1. So you want to add 1 on both sides, and that would be your answer. So if you added 1 on the right, you'd have t. But what if you added 1 on the left? Yep, add 1 on the left. Just x plus 1. Okay, so there's your formula for t. And now, what's my second step? What do I do with that x plus 1? Yep.
You plug it into the y equation.
Yeah, we're going to plug it in right there. So we're going to get y equals x plus 1 squared. And that's your equation. You could FOIL it out. We could leave it like that. That's fine. But there's my equation. Now, if you draw that, that's a parabola. But the original graph was not an entire parabola. It was restricted. So instead of your graph looking like this, your graph might just be that, from 0 to 3. We need to figure out what the restriction is on x. This is the restriction on t. So plug these numbers in and find the restriction on x. Let's start with the small variable, 0. If you plug in 0 for t, what do you get for x? Yeah.
X equals -1.
You get x equals -1. So let's just write that down off to the side, -1. And what if you plug in 3 for t? What do you get? Yep. 2. All right. I just figured out the low value and the high value for the x's. I don't need the low and the high value for the y's. When you write a restriction, you never write about the y's. You always write about the domain, which is the x's. So the x's are from -1 to 2. So if you were sketching this, I would want you to sketch this parabola, but you are only allowed to plug in numbers from -1 to 2. You can't plug in 3, you can't plug in -12. Just -1 to 2. Any question on it? So basically that's converting parametric to function by eliminating the parameter. Okay, I want you to know, we're not going to go through it in depth, but it is not always possible to eliminate the parameter. Like if I gave you an equation like this, good luck getting t by itself. You're not going to be able to. The problem is you have a t as a term and as an exponent. That's impossible. You cannot isolate a variable when it's as an exponent and it's as a term. If it was just a term, all I'd have to do is subtract the 4 to the other side and be done, because there wouldn't be a t on that as the exponent. If this t wasn't here, well, that would be not too bad, because I could use a logarithm. That's how you get variables out of the exponent. But having it in both spots messes us up. So I just want you to know, it is not always possible to do what we just did. Okay. So the last thing we'll look at is just practicing some sketches. I think the hardest thing is just figuring out a window. So. So the first graph we're going to look at is a circle. And what we're going to do is forget about like the entire circle. Just think of a single point on the circle. Like this. This point, we have an x value and a y value. So what we want to do is figure out a pair of parametric equations to represent that point. In other words, give me a formula for the x value, and then give me a separate formula for the y value. And that's parametric. Now, the location of this point really depends on two things. One thing it depends on is the size of the circle. How far out did you go from the origin? That's one thing. Think of this as a triangle. What's the other thing in this triangle that would control where that red dot ends up, besides the size of the circle? Anyone think of something that could change in the triangle that would move that point to a different spot in the circle? You can't change the hypotenuse of it. That would be changing the size of the circle. I agree. That would move the point somewhere else, like further out or in. But I'm looking for something else. Like what could you change in that triangle that would start to move the point around the circle? So there's something you could make bigger or smaller, and it would change the location of where that point would go. And the thing you could make bigger or smaller is something to do with the triangle. Yeah?
Is it the angle in the triangle?
The angle, yes. If you change the angle in the triangle, let's call this angle T. When we talk about parametric, T is something that can change. If you start to make this angle bigger, what would happen is this angle would get bigger and this point would start moving up. If you make the angle smaller, that point would move closer to the x-axis. So there are two things that affect where the point is. The size of the circle, let's call this R, and how big this angle is. And what we have to figure out for this point is how long this side is and how long this side is. The side that I just colored green, what would that be in relation to your coordinate? Specifically the length of the green side. Ashley?
Yeah.
So what is that in relation to my coordinate, though? Because my coordinate has an x and a y. Yep.
It's the x value.
It's the x value. The length of the green side is the x value of the coordinate. The base of the triangle is always your x. And what about the blue side? What would that be?
The y.
That's my y. So in order to write the equation of a circle, it all comes down to writing the equation for finding the base and the height of a triangle. But remember, this can change. As you change this angle and you keep r the same, you start getting other points along the perimeter of the circle. So let's write down our two formulas. What trig function would you use to figure out the x? You're going to know this, and you want to find it. Yep.
Cosine?
Yeah, you use cosine. X is adjacent. R is really like the hypotenuse. Adjacent over hypotenuse. So let's put it up here. Cosine equals, and Jake, in this case, what's my angle?
T.
T. Yeah. Why aren't we calling it theta? We normally use a Greek letter because we're doing parametric. Parametric, you always use a T. So the cosine of my angle equals. Chris, what side is adjacent to T?
That would be Y
No, y would be opposite.
or X.
X. X is adjacent. And Zach, what side is the hypotenuse?
R.
R, perfect. And what I want is x by itself. So what would go in that box if I get x by itself in that top equation? Yeah,
Or R times the cosine plus T.
exactly. These are the two things that would affect where the x value goes. The size of the circle and the angle inside the triangle. Now, we can go through it again, but without going through it, does anyone think they know what the y value would be? Again, it'll take into account the same two things, the radius and the t, but the y is in a different spot, so it's not going to be cosine. Matt?
R sine.
Yep. The top formula is the formula for the base. The bottom formula is the formula for the height. That's all you're finding when you're doing a point on a circle. How far over? How far up? Base, height, triangle. That's all you're doing. So R is the size of the circle, and T is the angle in the triangle. Now, they'll tell you the size of the circle. What they won't tell you is the angle, because that's the parameter. It's up to you to figure out what the parameter should go from. What's the T min? What's the T max? You'll have to think about it because we're drawing a circle. If you don't go far enough, you might get a picture that looks like this. You want to get a full circle. So let's try it. Let's find the equation of a circle, and I want the radius to be 2. So if I take the equations I just had and I fill in a 2 for R, what would my x equation be? Yep.
2 cosine T.
Yep. And what would my y equation be? Well, Casey, what would my y equation be? It's going to be very similar to x, just a different function. What do we got? We're going to, instead of cosine, we're going to use sine. Yep. Let's try to graph. Now this is a curve, so it's very important we set a t-step that does enough points. Okay, so press mode. Put it back in parametric if you switched. Type in 2 cosine t. Type in 2 sine t. Let's go to our window. Well, I know this is a circle with a radius of 2. So that means if you're at the origin, it's going to go 2 units every way. My window is set -2.5 to 2.5 on the x's and the y's. That's fine. The circle will fit on the screen. Now, I'm in degrees. And let me draw with T min 0. And let's do T max at 90. Now, stepping by 0.01 is too much. 0 to 90, stepping by 0.01, that's 9,000 points. Too many. I would do Even 0.1, that's 900 points. That's a lot. I don't know. I would probably even just go by, I'd go by twos. Go count 0 to 90 by twos. That's 46 points. That's pretty good. So let's hit graph. And that's what I get if I do a t-min of 0 and a t-max of 90. Did I get a full circle? No. So, what do you think I need to make my t-max to get a full circle? Yep.
360.
You need to make it 360. Now, it's not going to look like a circle, but it is a circle. Look at the ticks. It is 2 units in every direction. That is a circle. It doesn't look circular because you've set the screen as a rectangle, and you've set 2 units for the width and 2 units for the height, but the width and the height are different on the screen. So if you want to make it look circular, press zoom 5, and that'll make it look proportional. And now it looks like a circle. And you could see it started here, and it stopped at the same point. Now, let me switch over to radians. A lot of this could stay the same in radians. But what would you want your T-max to be? If this was radians. Yep.
2 pi.
You would want it to be 2 pi. Now, leave your t-step at 2 and watch what happens. Does that look like a circle? No. No. It's plotting a point at 0, 2, 4, 6. It's plotting 4 points. 1, 2, 3, 4, and then it's connecting them all. What would be a better step value? Because I'm only going from 0 to 6.28. I don't have an idea of what a better t-step would be. Well, should we increase it or decrease it? Okay. Okay, what do you want to increase it to?
10.
Now we have nothing. So it's plotting a single point at 0, and then you're telling it to plot the next point 10 units away, but we've already gone over our maximum. So we can't step in that big of an increment and have enough points between 0 and 6. Yeah?
Can you do like 1/5 pi?
Like let's just pick a decimal. You want to do like 0.2, 1/5?
Sure.
All right. So if we do 0.2, that's pretty good. I'd say that's fine. Because you're counting from 0 to 6 in increments of 0.2. So think about that. For each number, 0, 0.2, 0.4, 0.6, 0.8, 1. You're getting 6 points per integer. And you're going 0 to 6. So you're getting about 36, 37 points in there. That's pretty good. I would say if you go much less than that, like if you try 0.5, it's going to start to look blocky again. I don't think that's enough points. No. I mean, it was better than the first t-step I had, but also look at this gap at the end. That's because as you step by 0.5 from 0 to 6, you get 4, 4.5, 5, 5.5, 6. But the next point after 6 is 6.5. Well, I can't do 6.5. So try to pick a t-step that lands you closer to the t-max. I think if you pick 0.1, that would also be fine. It would pretty much give you the same result as 0.2, but it'll take twice as long to sketch it. And I don't know if you can tell, but there's a very small gap, and that's because my t-step ends at 6.2, and the next one is 6.3. So I'm never really getting that 6.28 in there. That's okay. All right, any questions on that? All right, so again, notice here on the screen, you only really have to go -2 to 2 to see the whole circle on the screen. But the parameter had to go from 0 to 360, or 0 to 2 pi. If you don't go to 360, you're only going to get part of the circle. If you go beyond 360, what's going to happen is the circle is going to trace over itself. And a lot of times what it does is because of rounding, it doesn't trace over itself in exactly the same spot. So when it traces over itself, it might do this. The circle actually starts to look a little bolder because it didn't trace in exactly the same pixels. That's because of rounding. All right, so let's try just a few other sketches and see if we can get good windows for them. Let's try this one. So it says x equals t cosine t, and y equals t sine t. So t cosine t, t sine t. And it tells us the parameter is 0 to 4 pi. 4 pi. So I'd like to know what to set my x min, x max, and all that to. So let's think about the biggest and the smallest value that x could ever be here. Start by just thinking about cosine. If you picture the graph of cosine, what's the highest that it ever goes? Yep.
1.
Goes as high as 1. And what's the lowest it goes? Yep. -1. So imagine that you got the biggest possible box, the biggest value you could have out of this box. It would be a 1. 1 times 4 pi would give me the biggest possible value that x could ever be. If this part was 1 and this part was 4 pi, x could equal 4 pi times 1, which is 4 pi. X can't be bigger than 4 pi. It's not possible, because this can't get bigger than 1. So 1 times 4 pi. Now, what did we say the smallest value you can get for cosine is? Yeah, -1. So now think about -1. -1 times 4 pi. That would be the smallest negative number you could get, -4 pi. You can't get like -100. That's not possible. You can only get -1 times 4 pi. It's as small as it gets. So I think we should use that for our x min and max. -4 pi and 4 pi. Now think about sine. What's the highest and lowest that sine goes? Yep. It's also 1 and -1, so you've got the exact same situation here. Y could never be bigger than 4 pi, and it could never go less than -4 pi. If you don't think about that beforehand, what you're probably going to end up doing is you're going to hit graph, and you may see a graph that goes off the screen, or you don't see a picture at all. So you could spend all day just guessing, trying to figure out where the graph is. But if you think about it a little first, when you hit graph, you'll get a perfect sketch that I guarantee you will not go off the screen. And that's the whole sketch. So this is the picture of a spiral. A spiral is basically a circle where the radius constantly grows. Gets bigger. That's a spiral. So in the homework, when they ask you to find a complete graph, I just need you to tell me what you used for the t values, the x values, and the y values. It used to just be the x and the y. Now I need to know the t. Yeah?
How did you get the graph? Because mine is just like a little square off. Doesn't show what you're showing.
So first of all, I'm in radians. So if you're in degrees, you would have to change your window significantly. If it was in degrees, this would say 720. So if you're in degrees, you're looking at an x min and x max of negative 720 to 720. Big difference. But please use the same units they tell you to in the problem. Okay. Any question on that one? All right, so you'll practice some more sketches in the homework, but not really by hand, just using the calculator. So let's take a look at this. Okay, I'm going to change a couple questions, so if you just hold off on writing it down for 1 second. Skip those two. Okay, I think everything else is okay. So I could actually just shorten that first part. That's really just 1 through 11 odd. I want to make that simple. So 1 through 11 odd, and then 21, 22, 25, and 29 to 32. And if anybody has any questions or the calculator wasn't working right, let me know. We'll take a look at it.